Hello, my name is Muhammad Noaim bin Yasmadi, matrix number 14761, first year student from School of Physics, study in Physics Engineering program.
My name is Fizmi Ali bin Adnan Ali, first year student from School of Physics, study in Engineering Physics program. So I'm the editor. Ta-da!
What's up guys, my name is Muhammad Zulfikar bin Zaini. I'm taking engineering physics course and I'm the presenter on this group, and on this video I'm going to present to you guys about the electromagnetic railgun. Hope you guys enjoy the video. So let's start! So, what is railgun? Do you want to shoot a projectile really fast but don't have any explosive propellant? Do you have little more than a couple of metal bars and a very big battery in your garage with which to do it? Then maybe you should look into railgun technology. Whoa! Based on rather simple principles of electromagnetism, a railgun is a system which uses electricity to accelerate a projectile to a mind-blowing speed of several times the speed of sound. Sounds crazy, right?
Wow!
A railgun is basically a large electric circuit made up of three parts: a power source, a pair of parallel rails, and a moving armature. Let's look at each of these parts in more detail.
Nice!
The power supply is simply a source of electric current. Typically, the current used in medium to large caliber railguns is in the millions of amps. The rails are lengths of conductive metal, such as copper. They can range from 4 to 30 feet long. The armature bridges the gap between the rails. It can be a solid piece of conductive metal or a conductive support, a carrier that houses a dart or other projectile. Some railguns use a plasma armature. In this setup, a thin metal foil is placed on the back of a non-conductive projectile. When power flows through this foil, it vaporizes and becomes a plasma, which carries the current. Now, you guys know the components of the railguns, but how does it work? An electric current runs from the positive terminal of the power supply up the positive rail across the armature and down the negative rail back to the power supply. Current flowing in any wire creates a magnetic field around it, a region where a magnetic force is felt. This force has both a magnitude and a direction. In a railgun, the two rails act like wires, with a magnetic field circulating around each rail. The force lines of the magnetic field run in a counterclockwise circle around the positive rail, and in a clockwise circle around the negative rail. The net magnetic field between the rails is directed vertically. Like a charged wire in an electric field, the projectile experiences a force known as the Lorentz force, which is named after the Dutch physicist Hendrik A. Lorentz. The Lorentz force is directed perpendicularly to the magnetic field and to the direction of the current flowing across the armature. Notice that the Lorentz force is parallel to the rails, acting away from the power supply. The magnitude of the force is determined by the equation F equal to ILB, where F is the net force, I is the current, L is the length of the rails, and B is the magnetic field. The force can be boosted by increasing either the length of the rails or the amount of current. Because long rails pose design challenges, most railguns use strong currents, on the order of 1,000,000 amps, to generate a tremendous force. The projectile under the influence of the Lorentz force accelerates to the end of the rails opposite the power supply and exits through an aperture. The circuit is broken, which ends the flow of current. For the railgun application, Based on the technology, there are a lot of railgun applications in our life. For example, of course, for the military purposes. Secondly, they could potentially launch satellites or space shuttles into the upper atmosphere using the railgun technology. For the electromagnetic railgun technology, of course, there are advantages and disadvantages. The advantages are, the first one is the speed. The railgun works by using extremely high electrical currents to generate magnetic fields. The railgun has a range of more than 100 miles. It fires projectiles that destroy targets not with high explosive, but by smashing into them at hypersonic speed. Secondly, the size. The smaller size free up a lot of space, which is better to use it for battleship. The third one is the area. Railgun cover biggest area compared to other missiles. This absolutely give a huge advantage during a war, as they can hit something within a long range. And for the disadvantage or problem, there are three problems. First one is the power supply. Capacitors must store electric charge until a sufficiently large current can be accumulated, while capacitors can be small for some applications. The capacitors found in railguns are many cubic meters in size. The second one is the resistive heating. When an electric current passes through a conductor, it meets resistance in the conductive material, in this case, the rails. The current excites the rail's molecules, causing them to heat. In railguns, this effect results in intense heat. The third one is the melting. The high velocity of the armature and the heat caused by resistive heating damages the surface of the rails. So, that's all from me. I hope you guys learned something on this video. So, see you next time. Bye!